Suppose tomorrow you will go for hands-on session, then I'll say increase depth, reduce depth, increase gain, reduce gain, increase TGC, reduce TGC. So what are all these words are? And what are the systems available on a machine? Only fact is, from machine to machine, vendor to vendor, things are little different, but they are ultimately the same. Correct? So this is what we say knowledge and optimization of machines. Let's focus on a system now. लेट जाओ बेटा, शर्ट उतार दो, बॉडी दिखाओ अपनी फटाफट. और क्या? इसको यहां रख दो, शर्ट को अपनी. We talked in the morning resolution, we talked about penetration, we talked about transducer, we talked about crystals. Prashar sir talked about pulse wave, Prashar sir talked about continuous wave Doppler, then Prashar sir talked about color Doppler. Can any one of you, what do you mean by color Doppler? What do you mean by color flow imaging? What is color flow? Based on a direction and velocity of a blood, a certain color is labeled to it. If the color is flowing towards a transducer, it's red. If it's away from a transducer, it's blue. Similarly, on a machine, can we shift on to machine? Okay. Change this to system. Change. So once we label a color, once we determine a velocity, the same color will be depicted on a screen. And how this color changes? Let it come in a second. Focus over here, then it will come. Okay. Now switch on colors. As soon as he switches on a color, what do you see over here? Red and blue. This is, Prashar sir, I have already told you, this is Nyquist limit. Correct? This is called as Nyquist limits. So as the blood will flow towards the transducer, it will show you red and yellow colors. If blood is flowing away from a transducer, it is showing a blue and then light blue or sky colors. What does this exactly mean by? It means by, I am talking of colors now, I am not talking color probes. It means by the velocity of blood towards a transducer, at its changes from this to this side, the velocity will increase. From here the velocity is 0, here the velocity is 62. Suppose I am seeing only red color over here, it means the velocity is almost 20-30. If I am able to see a yellow color, the velocity is 60. And after 62, what will happen to the color? Word is aliasing is right. In color, there is no word like aliasing. It's a turbulence or mosaic pattern. Aliasing is for Doppler. So once the color goes from yellow to more than 62, it will go to this side of a color. Correct? Can I have the screen? Just keep on, we are not going to change anything. Lights on. So what we are talking is, yeah, switch on, even that one also, great. And keep those lights on for a couple of minutes, be over there. If you happen to remember what we learned in our physics time, rainbow colors. Vibgyor, violet, indigo, blue, green, yellow, orange, red. Now look what after red comes. Violet, indigo, blue, yellow. Now look over there. After blue, blue, green, yellow, Vibgyor, sorry, blue, green, yellow, orange, red. So if my velocity goes more than 62, a wave velocity, it will be give you green or yellow colors. And that's known as turbulence or mosaic pattern. Are we clear or not? Because this is important. We talk of Nyquist limits. Okay. Let's come to the box in box picture. Let's focus. आप अपना कैमरा लेके यहाँ जाओ, घूम जाओ उधर, नीचे आओ थोड़ा सा, और नीचे चलो, और नीचे, हाथ सिर के ऊपर रख लो उधर. गुड. नाउ कैमरे को फोकस करो इसके ऊपर, स्क्रीन पर. जूम. ग्रेट. थोड़ा छोटा, बॉक्स बड़ा करेंगे. आप कैमरा इधर लाओ मेरे पास. लाइट ऑफ कर दे गोपाल, लाइट ऑफ करके आओ पहले. Right, now that's great, perfect. Now look, this is all jumbled of knobs are there. What are these jumbled of knobs? Now let's focus on this part, or bigger one. This is BM. Focus now. Great, zoom, 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 zoom. Good. This is BM. B mode and M mode. Correct? Now second knob is M. Only M mode. This is next CFM, color flow. Next knob is pulse wave, repeating frequency. We don't need them today. Next knob is pulse wave. Below the pulse wave on left hand side there is a continuous wave Doppler. So what we have right from B mode means whatever this B mode is over there. Suppose I am pressing this B mode. Look, the colors disappeared, is only a B mode which is available over there. On the other side, we have this scale over here. Can you see this scale? This scale is how much? Is 15 centimeter over here. Correct? This is 15 centimeter of depth. सुन लो आप, 15 centimeter of depth. I say increase the depth. So let's look at this knob over here. This says depth. It's written over here is depth just behind. So if I am increasing, look, my depth is increasing to 20 and I'll needing more of the structures. So what will happen if I need a big penetration, huge chest wall patient? I need a depth to look at his heart. And suppose I need a child or a neonate, I don't need a depth. So my depth is reduced. Here the depth is increased. So thick chest wall patient, we need a bigger depth. For thin chest wall person, we need a smaller depth. So this knob left and right will increase the depth for a patient. Clear? Second comes, look at this knob, it shows B. I want to increase the gains. Is it generalized gains I have increased? My gains are less, so I have increased my gains. Most important thing, look over here, These gains are good, but these gains are not good. So I move to this side, इधर की तरफ focus करेंगे. These are known as TGCs, trans gain compensations. And now I want to increase the gains over here. I am going to increase my gains. Now it's equal. Now it's less. Look, I have reduced my TGCs. So TGCs means selective gains. B mod gains means generalized gains. Suppose my gains are over high. So what I am going to do is reduce my gains. If tomorrow somebody tells you increase the gains, ask him generalized or selective. Selective are done by TGCs, generalized gains are done by B button. And it's there in everybody, it's only the name is different. My name is Rakesh Gupta, your name is Suresh Gupta. But ultimately it's a B gains only. We are clear about gains, we are clear about depth. Okay, next let's come down to pulse wave. Once I say pulse wave, so what exactly has happened? Once I said pulse wave is, here is a baseline and here is a pulse. Now pulse wave means it is measuring a velocity at this particular point. And how do you reflect on a screen where it's measuring a velocity is? No, machine tells you at what distance it's measuring a velocity. Anyway, not for that matter, this is pulse wave Doppler. Pulse wave would be used, as Parashar said, for selective place. Suppose I want to measure a velocity at this particular point. I will be using pulse wave. Suppose I want to measure a velocity across this whole of this line. It will be a continuous wave. Pulse wave will be able to measure low velocities. Continuous would be measured high velocity. How do you say this? Now look at the scale over here. Pulse wave velocity scale is 125 over here, 122 over here. So how much maximum velocity it will measure? 1.22 plus 1.25. Suppose I take my baseline up. Now this is the maximum, so it can measure up to 2.46. So any velocity you can measure is up to 2.46. Okay. How the baseline goes up? Now focus on this. Here's a, no, focus on this also. Yeah. Now look at this word written baseline over here. And here is a knob. So with this knob, I have moved my baseline up and down. Correct? Same way, if I switch on my continuous wave Doppler, look at the velocity, how much it has happened. It's 2.94 and 4.76 meters per second. And if I move my baseline up, if I move my baseline up, I can measure a velocity of almost 7 meters per second. What's the utility of all this? Why continuous wave, why pulse wave? Normal velocity for a valve is 1.7, remember two figure, aortic 1.7, mitral is 1.3. Half of that is aortic is pulmonic, half of the mitral is tricuspid. So in normal valves, the velocity required is not high, 1.7, 1.2 maximum, 2.5. But when the valve becomes pathological, then you need a higher velocities. So if I am measuring a velocity, if it's a, normally we put pulse wave, if the velocity is well within normal, we are not bothered. If we are not able to take care by baseline as well as by what? We can only measure the baseline, change the baseline. If we can't do that, we switch over to continuous wave Doppler. Clear? Alright. Parashar sir must have told you another thing is color gains. How do you say this is a color gains button? I have switched on my colors. Now I am increasing my colors. So these are all jumbled up. How do you say gain optimization? Now I am reducing my colors. So when hardly any speckles are seen, it means that's my optimization of color gains. Otherwise, if I'll reduce my color gain substantially, I may not be able to see color jets. Clear? What else is left on a screen? Yeah, this is focus on this trackball. What does this trackball does? Move my cursor, color box from left to right. Similarly, it will take my cursor of pulse wave and Doppler wave also. So this is scrolling. These two buttons on either side of this ball, this is reject, this is accept. Reject means suppose I have fixed up my colors, I want to increase my box size. Now look, I have increased my box size. I have to fix this box size, otherwise it will keep on moving. So I'll put this accept, not over here, accept this. Now it will fix up on this. Similarly, if I measured my velocity and I have to accept it, how much is the velocity? So one we say reject, second we say accept. Come down to lower side. This is freeze. So in total, whatever all we need, it's there. Second issue comes, let's come to one more issue. Now look at the size of this box. We call them as sample volume size. Normally it's 2 to 4 millimeters. Look at over here the screen. Sample volume 4 millimeter and presently it is present at 11.7 centimeters from here. 4 by 11.7 centimeters, 117 centimeters. I can change this sample box by, show this, zoom it up, no, go down, go up, thoda sa upar chalo, bas. Look at this sample volume size. So I can increase this sample volume size, I can reduce this sample volume size. At your level, remember we need a sample volume size of 2 to 4 millimeters. And this is what knobology is. Okay. Now let me show a live orientation. Now you know what are the keys are. Sample volume up and down. Here is the sample volume. You track this up. If you want to change the size of sample volume, here is a machine. No, don't go. Here is the sample volume size. So you can move with this sample volume size. Clear? Up and down by scrolling. This is a scroll. And one more thing, like and our humble request is please always start doing echocardiography with ECG gating. Let's adopt one principle, no echo without ECG gating. So I am scanning my 4-chamber view. Now he is reducing the, just hold on. What he is doing? He is doing image optimization. What image optimization we need to do is, first of all, let's adjust the depth. Now look, the lower depth, like the structures which are present over here, they are very hyper-echoic, correct? So I am reducing my whole depth, then reducing my TGC of the lower region and increasing the TGC of the upper region so that you can see a good apical window. Now this is image optimization. Correct now? Your image could be like this. This is good. What's wrong about it? सब कुछ अच्छा अच्छा दिखाई दे रहा है, गलत क्या है इसके अंदर? दिस इज समथिंग लाइक a boy in, I belong to Warangal. In Andhra, a couple of my colleagues used, they were black, they used to put lot of powder on their face. Don't mind me, it's not nothing personal. And they used to get for me also. So like, how much powder it is put? But what we need is, we need the image optimization. Look, this is an image which is a natural image. This is 2D optimization. And look, depth is almost 12 to 15 centimeter in every subject. We should be able to see a descending aorta here. This is pulmonic vein, he is a descending aorta, rounded structures. So we should incorporate descending aorta, we should be able to see a good endocardial delineation. Is that correct or wrong? Convince? Pardon? Go ahead. So second thing is now color. Now how do you say my colors are optimized or non-optimized? I am going to increase my, look, I can say many colors out there. So I am going to optimize my colors. Still garbage is gone away. Those speckles have gone away. Can you switch on this, off this camera? Switch it off, Anand? No, switch off this camera. Show machine only. Good. Now this color has got a certain Nyquist limit, which we talked about. 62, correct? All system when we are doing is, we should keep a Nyquist limit of, reduce kar do, 50 to 60. That's it. No, 50 to 60. Ideal Nyquist limit is always 50 to 60. Suppose I am increasing my Nyquist limits. What will happen? Let's see. Increase. Okay. I'll start losing my colors. Which colors? Low velocity colors will start losing. In case of pulmonic veins, I need to have a velocity, low velocity, like 30. It's showing a very good flow in this machine. Normally is not seen this much good flow in pulmonic venous flows. This machine is a new one which they have recently introduced, and we are fortunate to have first one in India at our place for demonstrations. Of course, if they give free for lifelong. They are not going to do that. रिकॉर्ड कर लेना भाई, इसको भेज देना वहाँ पे. नहीं नहीं, साउंड रिकॉर्ड करके भेज देना मोहनलाल के पास. फ्री दे रहे हो तो एक रख लेंगे यहीं पर. करेक्ट? So this is color optimizations, color gain. Now second thing what I was saying is, now I'll take a pulse wave. I am keeping a sample volume distal to the tip of the leaflets. So now this is, I am measuring is velocity, correct? Now if I measure a correct velocity, I should accept a button on the right hand side. Show this button. Let's get to box again. Anand? Yeah. Now chota karo, small, reduce, zoom कम, zoom कम कर दो बेटा, छोटा करो, zoom कम करो, कम करो, कम करो, कम करो और कम करो, इसके ऊपर फोकस करो. Good, बस बस. Now this is accept. Now I have accepted. What you see, what happened over there? It's become fixed now. And say I do not accept, I'll say unaccept. So this will go. So once I'll say accept, measure, accept. Similarly, we can trace this. You go to measurements, I'll trace this mitral. I am going to trace this whole envelope. Can you get rid of box now? Camera off kar do. Now look, once I have traced this and I have accepted it, what does it gives you? It gives you a peak velocity. It gives you mean gradient, mean velocity, mean gradient. All three figures it will give you. It has given you many things, but what all we need is peak velocity, peak gradient, mean velocity, mean gradient, and velocity time integrals. Correct? VTI. FVI, flow velocity integral. I said name is different. Suresh Gupta, Ramesh Gupta, Shyam Gupta, Ram Gupta. But things is the same. What is VTI? The amount of the distance with which the blood flows in each stroke. So with stroke it's traveling at 15 centimeter. This blood from here to here has traveled 15 centimeters with one mitral valve opening, with one diastole, E wave, initial opening. It has got values. It has got many values over a period of time. Clear? No clear. Too much of a things in one go. We have not talked hi-fi, we have just talked basics. Trying to restrict to just basic level, ground levels. How do you change the Nyquist value? Now the camera on. Now let's go to B scan. Correct? Can Anand move this camera to other corner? Right corner, right top corner. Take it up, up, good, very good. Here, no interference. Now, focus on this. Focus over here. There is a scale word written over here. Thoda sa niche lao. Here is a scale. Correct? Now I can you see that? I am spending time so that this problem is not there tomorrow when you are doing hands-ons. And this was a feedback from one of the previous group, sir, knobology. So you can change Nyquist limit, you can change pulse, you can change continuous wave Doppler, you can trace peak and mean gradients. I am going to demonstrate further that. Any question by now? Go ahead, ask me instead of asking him. 50 to 60. Not color gain, Nyquist limit reduced to 30. Why it is reduced? Because pulmonic venous flow is around 30 centimeters per second. How to increase the spectral angle? Focus. Right. There are three buttons on top of this machine. This is reject, this is accept, and this is the third button. I am pressing this third button. Now, color, correct? And whatever you do, then press that button again. Now your question comes, how can I increase or reduce this angle? Another question. So what we do is, now focus on the machine, this point. It says size. Now I am increasing the size, reducing the size. And if you happen to look at this corner. If I am wide opening it, my frame rate is going down. If I am reducing this, my frame rate is going up. But I have to keep a sector at around about 60 to 70. And that is seen in the system. Now focus on this machine over here. Look at this sector. It shows size 55 degree. So this angle is 55 degree. Where do you need a smaller size? Where you want to zoom up a mitral valve. Suppose you narrow it down, just focus on mitral valve, AML, PML, and you want to look for a prolapse. So you get a very high frame rate with this. Right, very good question. Which mobile do you have? I'll answer in your question only. Can I show you a mobile? No, a smartphone. Which mobile? कौन सा है ये? जियो. वंडरफुल. पकड़ो अपने पास वापस. सबसे अच्छी फोटो किस में आती है? No. Which phone says I've got the best photograph of that? जिसका highest pixel होता है. Now you got the answer. Again, Ramlal, Shamlal. Higher the frame rate, higher the pixel. You got it? If you have a very high pixels camera, you will have a good resolution images. If you have a higher frame rate, you have a good resolution. Angle of incidence what?
Angle of incidence of what I interrogating with the introducer to image structure. Is there any knob to localize this? 20 degree, 30 degree?
You can only zoom up that structure. If I am able to understand you correctly, घूम जाओ. There is one button which is present as depth. Depth was rotation, correct? If I'll press that button, it will, now it is which structure I have to zoom up. Now this is selective. What does it mean by? I am only focusing on this particular picture and especially mitral valve. If I am able to move it further, it will give me a frame rate of almost 80 frames per second. I hope that answers your question. That's what you were looking for.
My query was the ultrasound beam to that structure, which is called sovereign angle of incidence.
Not me, Prashar sir maybe. Maybe later on we'll try to explain what exactly are you looking for. Frame rate means higher the frame rate, better is the quality. I gave an example for pixel is higher the pixel, better is the camera photograph. It's an inbuilt one. We can go as high as the frame rate is. Look, that's another good question. Look, this is what the frame rate of this machine is 102, correct? How much maximum frame rate I can take this machine to? Let me try. 278 frames. So if this much of an angle of interrogation is 35 degree, my frame rate is almost 160 frames per minute, per second. And it's changeable, as Prashar sir said, it's changeable. Like as I'm increasing this sector, frame rate is decreasing. This frame rate will further decrease. Now, same transducer is only doing 2D imaging. I set the transducer to do color Doppler. It has dropped down to 24. I set this transducer to do a pulse wave. The frame rate has significantly dropped down. Where is the frame rate now? No, this is a scale. The frame rate would be further less. Because the same machine now is doing 3 different jobs. Correct? And this is the reason why we want to keep a sector volume of a color as small as possible, because every point it is utilizing energy. Pulse Doppler, it's utilizing energy at this point only, but for color it's utilizing energy in whole of this box. So frame rate dramatically drops down. Now another important issue, you switch on this color, look at the frame rate, drop down to 24. Now I am widening up this 17. How much energy it has consumed? Off colors, on colors. From 93 directly to 70. And less the frame rate, poor would be the quality. Now for frame rate. Here is the frame rate. Beta focus karo. Here is the size. As I am changing the size of the box, frame rate is changing. Second, if I switch on a colors, if I reduce this box, the frame rate will improve. So every part will need a frame rate corrections. If you will make smaller one, what exactly I will do? Suppose I am looking at pure mitral valve. घूम जाओ, हाथ ऊपर ले जाओ. Suppose I am looking at pure mitral valve, correct? So I will reduce my frame rate. First of all, I will reduce my size 180. Second, I will switch on a colors. I will switch on my color box to as it incorporates to mitral valve. Now I am framing at 33 frames per minute per second. This is not frames per second, this is hertz, but let us presume that hertz is frame rate. Correct? Got my point or no? And same patient, now I am changing, now go to 2 screen, first of all, yeah. Now go to second screen, correct. Now same patient, what I am going to do is, first of all I am increasing my size, second I am increasing my box, now I am acquiring a clip, and my young friend will play both the clips together. दिखाओ दोनों clips. Mean to say this, as we reduce our hertz, we will have poor imaging quality. As we increase our hertz, we have a good imaging quality. Clear or not clear? We spend almost an hour on knobology and these things. Okay, shall I move further now? Normally, we do not increase sample size. Only fact where we increase sample sizes. As smallest is not possible. Once you start doing it, then you realize it's not really as smallest. Okay? Any questions before I move further? You want a cup of tea or coffee? So, huge number of measurements which we have today, but we are not going to look at all those measurements. We are going to look at only specific measurements which we will require every day in your practice. Now, first measurement is in plaques window. घूम जाओ उधर. बगैर काम किए सोने को मिलता कहीं पर? तो बता आज तक कभी किया तूने? Gains, you know. Now he is trying to optimize the best possible gains. I like the imaging quality of the system. Size is good. That's it. So what we promote all the time is, and we draw a line. Where is the line? Right into the center. This is plaques window, correct? I am intersecting what? Aorta and aortic valve leaflets. So I am going, hello nahi beta. So I am taking an M mode. Then move my cursor to the tip of the mitral valve leaflets and then distally. Did you see what I did? I did not do anything except for the fact I started scanning. Pointer देना हो जाएगा. I started scanning in plaques window where aorta was almost horizontal. Clear? I have dropped a line right into the center, and if this sector is 60 degree, the line is at 30 degree. 30 degree this side, 30 degree this side. So I am intersecting my what over here? RV. So this is RV free wall. This is RV during diastole, and this is systole. Then this is aorta. This is right coronary cusp. This is non-coronary cusp. This is aorta posterior wall, which is anterior to LA size. So this is LA. Behind the LA, what is the structure is? Descending aorta. Correct? Now, where to measure aorta, where to measure aortic valve, where to measure LA? When aorta would be the biggest in size? Just at the beginning of systole. So where is the systole by ECG getting? Here is the beginning of QRS complex. So aorta will measure over here. Correct? Where will be the LA is bigger in size? Beginning of diastole. So end of T wave would be beginning of diastole. Clear or not clear? Then aortic valve opening from one valve to another valve. When the aortic valve will open? Beginning of systole. So let's try to measure them. And there's many way to measure it. You can directly go. Now let's focus. No, आप हट जाओ. उस कोने में बॉक्स नहीं, हाँ इस कोने में बॉक्स बनाना आपकी बार, या वहां बना, उसी कोने में बनाओ. आनंद जी, गुड मॉर्निंग यंग मैन. नो सॉरी. सैयद जाकिर हुसैन, आपके लिए सोफा आगे. कम 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 कम. दिस इज रिजर्व्ड. आ जाओ, कम कम. लेट्स गो एंड सिट ओवर देयर. Now let's look at this. Zoom it up. Here's the word line. Could you see this word over here? Right? Line. Line oblique update. And now move to this scroll over here. Now once I scroll this, once I'll scroll, look, this image will start moving. I'm scrolling now. Now this cursor will go to the tip of the mitral valve leaflets. So mitral valve will open up. Now this cursor is distal to the tip of the mitral valve. Now LV will come automatically. Correct? So let's go back to measurements. Now in measurement, focus in these two. Zoom up it. There is one measure, one caliper. Correct? So I am going to use caliper now. Now small it up, छोटा कर दो, इसको यहाँ तक दिखाओ. Good, बस. I am going to use caliper. Now look at the machine. I have got the caliper. I am saying from this point is iota. I will say enter. So I am entering it. Now I am scrolling it down. Enter or set. So here is the measurement 3.2. Now I have done iota in systole. I will measure. Now second point is LA. Upper wall to upper wall, leading edge to leading edge. I didn't want to touch that topic, but you have made me to touch it. This echogenic focus has got, this is a leading edge, this is a trailing edge for this focus. M mode calculations are always in leading edge to leading edge. So this is a leading edge for here, this is a leading edge from here. Now this is the leading edge for this echo window, echo image, and once I'll touch it, I'll say enter. Now this is, suppose this is wrong. So what I'm going to say? Escape. Now I'm, or else I'll go back to measure again and now come back and then measure my enter and what's the LA size now? 36. Third, I have to measure aortic valve opening. So leading edge, now the questions comes, where do I measure? Possibly this is an image which is 23 millimeters. So in plaques window, aorta, LA, AV cusp separation. First three measurements. Now let's save this image. Now switch off measurement by pressing measure. Now I am scrolling my image now. Out of these, I have to look for the best M mode. I am going to say measure now. Look, as soon as I click measure, mitral valve, Gopalji. D point, this is E point, this is E point, this is F. So EF slope, D excursion. Although this is not the right value, this system has to be opened up. Once we will go to their hands on, then we can utilize other systems. I am back. Now I am scrolling it for LV. When is the LV bigger in size? At the end diastole or beginning of systole. So where is end diastole? Here. So you will measure LV in, this is diastolic LV, and at the end of systole, this is systolic LV. Clear? So let's measure this diastolic LV. Good. In this, I have used measure key. As soon as you measure right ventricular diastole dimensions. So where is the right ventricular diastole dimensions? Here or here? Same as RV dimensions, same as LV dimensions. So I am going to scroll to this point. I will say enter. Now I am pushing enter button. Now it will come down to, this is RV dimensions, 25. Now it is asking you what IVS during diastole. So this is IVS during diastole. I said enter. It is in continuation. Now LV dimension during diastole. Now this is 51. Enter. Now it is asking posterior wall diastole, diastolic dimensions. So this is posterior wall diastolic dimensions. So what it gave you? IVS during diastole, posterior wall during diastole, and LV dimension during diastole. And if IVS thickness is more than 12 millimeters, then we say LV hypertrophy. During diastole, systole they will all be thickened. Now, once we have done this, we will go to systole. Where the systole begins? Look what is asking, IVS during systole. So, this is my IVS, same where we did diastole, here is a systole. I say enter. Now, look, IVS has become from 9 to 12. Now, it is asking LV dimension during systole. Now, systole 37.5 from 51 to 37, almost 33% change. And now is asking posterior wall during systole. So, my posterior wall during systole. It has got ejection fraction of 52, fraction shortening of 33, LV mass of 175 grams. How many of you will take those guys who were doing echo? How many of you will take ejection fraction as 52 in this subject? This is right or wrong? Who said wrong? Why?
Because it is a two-dimensional. We are not considering whole of the, because it's an injection fraction, so we cannot take a volume in two-dimensional.
No. Oh, wait a minute, I will come down to it. Just give me time.
We are getting in one axis only.
Right. We are only interrogating septum and posterior wall. Suppose mid septum, mid segments are involved, apical segments are, we are not utilizing them. So, we will never take this M mode ejection fraction ever in practice. Only thing what we consider is fractional shortening, which is almost 33%. It's 26, approximately 30-33% is the normal ones. Okay? Ejection fraction always by 4 chamber, 2 chamber view together and their average. Any question for this measurement out here? Because this is what we all expect from you. There is one more point which is left apart from this, and it has got lot of values. This is a point which is known as E point septal separation, and normal is 5 to 7 millimeter. Let us talk 7 millimeters. Pardon? 7, I believe 7, sir? 7 centimeters, 0.7 centimeters or 7 millimeters. If it becomes larger, it shows two important things. One, LV is dilated, second is poor ejection fraction. Where does the heart enlarges? Which part of the heart enlarges? This is apex, this is base, and this expands. Has this ever expanded? No, this has never expanded, only this expands. Belly. So, this is the belly of the heart. So, if this point goes up, LV appears dilated and poor ejection fractions. Prashar sir will show a slide where based on EPSS, you can say how much is ejection fractions.
MRI is supposed to be a very important measure for LV function. And they found that the EPSA was more than 17.3. The ejection fraction was less than 30. That was 17.3 according to them.
So, we have measured LV, we have measured aorta, we have measured LA, we have measured aortic valve openings, DE excursion, EF slope.
In this condition, the EPSA is not valuable.
Place where mitral leaflet get restricted. Possibly Prashar sir is asking the same thing.
Aortic regurgitation, LV function normal, but LV is enlarged.
Window. Now, another important thing which you will be measuring every day is what? एको का नाम आते ही सबसे पहले क्या चीज पूछते हैं? इजेक्शन फ्रैक्शन. And we'll try to prove in next 7 days ejection fraction does not carry any value. Echo is much more beyond than ejection fractions. So let's see how do we measure ejection fraction. बेटा आप इस कीज पे बोर्ड पे लगाओ, मैं बैठ जाता हूं, की को जूम करो. Now this is the most important thing is, for ejection fraction what we need to have? We need to have a very good endocardial delineation. So I have to optimize my image. Can I have the pointer? Look, this apex should be in the center of this triangle. थोड़ा box छोटा कर दो आनंद जी, और छोटा करो. At this point, many people of you who are doing echocardiography must be feeling a pressure that how to look for a good endocardial delineation. Correct? So just manipulate your probe and ask the patient to hold his breath in end expiration or inspiration. Here we are not measuring velocities. Now what exactly happens with this patient? Can anybody say? With inspiration his imaging is overlaid by lungs. So I am going to ask him, सांस छोड़ के रोक लो, hold his breath after expiration. सांस छोड़ के छोड़ो, बस रोक लो. Okay, ले लो सांस. Don't tell him to hold his breath for long. सांस भूल जाओ. सबसे अच्छा सिस्टम क्या है? जो करना उसका अपोजिट बताओ. It's a hard fact. If you tell him to hold his breath in inspiration, he'll hold in expiration. You tell him to hold in expiration, he'll hold in inspiration. These are practical issues. Now what I have done? Now I have got my images which is maximum in size. And look at the cursor, where the cursor is. No, cursor is over here, not here. This is yellow. Now look at this. I am going to move it for you. Correct? So when does the systole starts? Beginning of QRS complex or later on? Beginning of QRS complex is over here, and LV has not contracted till this point. Why? There is a one word which is known as isovolumic contraction time. So this is all isovolumic contraction time when aortic valve has not opened up and mitral valve is already closed. So I will look at this point where LV is maximum in size. Now I am going to look at this. Now look at the probe, measure. I am going to press it, bring it down atrial length, and then one annulus to another annulus. I will start with medial annulus. Now look at my button, enter. Now I will trace according to the endocardial delineation. And many of us always presume a lot many things. So am I. And bring it down to lateral annulus and then enter again. So it gave you what? LV area during diastole. Now it's asking you dimension, length. So center of this point, enter and go to the apex. So it gave you an LV volume during diastole. It's not LWD, it's LVVD. LV volume during diastole. So this is 81 mil. Now I am scrolling with the scroll. Now to get the smallest possible. Correct? And look at the cursor. Cursor has gone beyond this T wave. I'll press measure again, bring it down to medial annulus, trace the endocardial border delineation, exclude or include whatever you want to do with the papillary muscle, but you should do both the times. That's area, center of this gives you volume, and now this is your ejection fraction, which is a global 4-chamber area. This is area, this is length. So this is area length method, 4-chamber ejection fraction is 53%. Pardon? By chance. It's not true. Now I am going to do this same thing in 2-chamber view. Very difficult. Number of times become really difficult to make a good 2-chamber view. सांस छोड़ के रोको. देख लो मैंने क्या कहा था. ऐसे छोड़ के रोको, इसने खट से अंदर सांस खींच लिया. छोड़ अंदर लेके रोको. अरे दोनों काम इकट्ठे नहीं करने, छोड़ दो अब इस बात. बस यही रोक लो, अपना सांस नहीं लेना जब तक रोक सको. I'm gaining up for a reasons that I want to see endocardial. छोड़ दो, छोड़ो, रोको, नहीं छोड़ो, यही रोक लो. गुड. अरे यार, रोक के रखना. Now is the difficult things. Most important thing is this is true 2-chamber view. Here is the papillary muscles, inferior wall, this is chords and this is mitral valve. So I am going to trace the same thing during diastole and systole. Not a very good imaging quality, and I am going to now presume many things. Apex I can't see. Now smallest one. Measure. Same I'll trace. So almost 50% ejection fractions. So this boy has almost 53 plus 50 divided by 2, almost 52% of ejection fractions. This is what is recommended today, at least by biplane view. And best would be triplane. Use a apical long axis and then you give you global ejection fractions. Next 10 minutes, 5 minutes I will adopt.
How to record
There is this show. पास में आ जाओ. दिखाओ, बॉक्स दिखाओ. Here is the 2 images. This shows image, so it will store the image. If you press clip, it will store the QRS complex. Even ECG will help you at this point also. If your QRS gating is there, so you can feed in a machine how much clips you want, how many ECG cycles you want. Ask him 1, 2, 3, accordingly he will store those clips for you. Right? Now, apart from this measurements, what all we need to look at is, we need to look at the Doppler flow velocities. Sir, shall I show those Doppler flow velocities? दिखा दिया. You see all the valves and all? You saw peak and mean gradients, everything? ठीक है सर. So I'll stop at this moment. So this is what M mode 2D measurements, how to look for ejection fraction, what is the nomology, what all the waves are, what we require. Any questions?